Hello, and welcome to the FlipRobot e-learning module. This module is for the overview of Actura's FlipRobot in-class solution. In this course, we will cover the following topics: the importance of STEAM-related skills and how robotics is an effective method to teach these skills, the various components of the FlipRobot hardware and what their function is, the FlipRobot environment and the various resources available on the platform, an introduction to Flip code, an overview of the case curriculum used by FlipRobot. When you finish this topic, you will have learned robotics applications in STEAM learning, the hardware components incorporated with the E300, the resources available in Flip Cloud and how they can assist you in classroom delivery, how to access Flip code and some of the features of the platform, and what is included in each topic of the curriculum. We all know how important STEM skills are to the development of students, but it's how important they are which can surprise some people. According to the Office of the Chief Scientist of Australia, 75% of the fastest growing occupations in Australia will require STEM-related skills. Couple this with the fact that on an average, a person will have 5 to 7 career changes in their lifetime, means that having some STEM-related skills will be more important than ever before. Robotics is also an area that is becoming increasingly prevalent in today's job market. We will now run through a couple of examples of industries where robotics is becoming more important. The amount of industries that utilize robotics is growing every day, and the applications vary far beyond conventional means. We will now look at 4 areas of business and how robotics is impacting how these areas operate. The medical industry has been using robotics for quite a while in a surgical sense, with advancements in robotics to assist in keyhole surgeries as an example, but robotics has evolved beyond this. Microbots are now being used to deliver antibiotics into the bloodstream, which require robots to be built that are less than a millimeter in size. On the other side of this, robots are also being used to comfort younger patients by means of providing automated pets to ease stress. While robotics in the medical industry are designed to heal, in law enforcement they are designed to prevent harm. Robotics in law enforcement is about replacing humans with artificial intelligence in high-risk situations. This includes such activities as bomb disposal, crowd control where drones are deployed, and some prisons are even employing robotic security guards to minimize risk to staff. In the manufacturing sector, robotics have been used to complete systematic and repetitive processes. This includes such things as the classic assembly line, which has been used in the automotive industry for years. Companies such as Amazon have also taken to making all their logistics operations automated, with robot arms picking and packing items sold through the Amazon platform. Not all robotics involves having a physical robot, but rather utilizing the coding elements behind it. In the world of finance, coding is used to calculate the millions of low-level transactions that banks and credit organizations need to operate. This can include things like running financial risk assessments, evaluating credit limits, and various other banking duties. The benefits of robotic STEAM learning go beyond their application in the workplace, with robotics also being a valuable way to impart soft skills onto students. Examples of how soft skills are taught are encouraging the use of critical thinking and problem-solving skills. Through being assigned various challenges that a robot needs to be programmed to overcome, students grow their problem-solving ability as they work to find the resolution. Students will work in groups when solving these challenges, and as such will require collaboration and effective communication to achieve outcomes. Being able to work as part of a team is crucial when working on a collaborative effort in the workforce. The act of building not only the robot, but the different codes to perform the various activities for FlipRobot helps nurture curiosity and imagination in students. With the various combinations of extension kits and coding options, FlipRobot allows students to show off their creativity in how they want their robot to be built and function. There are also many ways to solve robotic problems, and as such this promotes agility and adaptability when working on assessments. Knowing that one way may not be the most efficient way and working on improvements is key to being successful in the workforce. Robotics provides one of the most thorough STEAM learning experiences available amongst other courses, with the course providing a combination of both ICT exposure and hands-on interactions, training for future careers with the growing trend of occupations utilizing robotics, and creative ways to continue learning the variations available in higher level robotics from both a hardware perspective as well as the varying coding languages available. We will now look at the components that make up the FlipRobot solution, including the FlipRobot hardware, Actura's FlipCloud environment, the FlipCode online coding environment, and the case curriculum. Actura's FlipRobot framework was designed to provide an easy to implement but also comprehensive in-class robotics learning solution. At the center of the solution is the case robotic curriculum. It is from this curriculum that the rest of the solution was created. Our curriculum was created by our global education partner, the California Association for STEAM Education, or CASE, with Actura then mapping it to Australian standards. Our curriculum is mapped to be Acura compliant and focusing on building STEAM-related skills in students. The FlipRobot Learning Kit comprises the hardware and software platform to help deliver the case curriculum. The hardware was developed to provide a comprehensive range of configurations, with not only the starter kit but also the extension kits available. This is supported by FlipCode, Actura's cloud-based coding platform, which allows access from any device that can have internet connectivity. The last element is our professional development programs, which are designed to provide teachers with the knowledge and skills to implement FlipRobot into their classrooms. Our professional development course for FlipRobot has been certified in many states and territories across Australia and New Zealand, and focuses on building not only hardware and coding knowledge, but also curriculum building for teachers to come up with an effective lesson plan for their classrooms. This is all underpinned by the 7 survival skills devised by Professor Tony Wagner, which are the transferable skills Actura believe are essential for students to succeed in the modern workforce. We will now look at the components that make up the FlipRobot hardware, discussing their purpose and function. The chassis is the backbone of FlipRobot. Made from resistant materials, it was designed to handle extensive physical use that would befit a classroom setting. What you may also notice are the various holes and gaps that are not being utilized in the build of the starter kit. This is because they're there to handle the additional parts of each of the extension kits, as you can see here. The chassis needed to be adaptable to these additions, so we have ensured this is the case. The FlipRobot starter kit is a wheel-based robot because it provides a good introduction to coding movement. Each wheel is powered by a DC motor, meaning each wheel can be individually programmed. This setup allows students to not only become familiar with wheeled movement, including single and double wheel rotations, but also with calibration, as the motors will need to be programmed to run at the same speed and same direction. As the name would suggest, the Flip Brain is the central processor for the FlipRobot. It is here where FlipRobot takes information given to it by its various sensors, such as the ultrasonic and infrared sensors shown here, and utilizing the coding provided to FlipRobot will command the various outputs to react accordingly, some of these outputs being the DC motors and RGB LED lights. The variable control board plugs directly into the Flip Brain as shown here and acts as a physical programming interface for FlipRobot. By turning the dials on the variable control board as shown, different programs can be run using the ultrasonic and infrared sensors. If you wish to learn more about programming through the variable control board, Actura has an e-learning module covering this topic. The FlipRobot starter kit comes with 2 sensors as standard, these being an ultrasonic sensor and infrared sensor. The ultrasonic sensor shown here is used to sense incoming objects and obstacles and can be used for obstacle avoidance and maze challenges. The infrared sensor shown here is used to detect differences in light reflection. The infrared sensor is primarily used for line tracing activities. We will now look at Actura's FlipCloud online portal and the tools available on it. The FlipCloud environment is broken into 4 key areas. These are Knowledge Base, Case Curriculum, FlipCode, and Actionscript. Knowledge Base is FlipCloud's primary support hub for FlipRobot. In this section, you will find a vast array of FAQs and support-related questions that have come from the development of FlipRobot, as well as the queries raised by our advisory schools. The Case Curriculum section is where the online copies of our case curriculum can be viewed and downloaded. This includes the program designs and teaching resources. Along with this, the default firmware for each topic, as well as coding samples for each topic, which we will discuss later in this module. FlipCode is our coding environment where students can start coding or load previously saved code. Actionscript is our online visual coding platform. This is applicable for SA2 extension kits for the FlipRobot and allows actions that will come from programming to be viewed on the platform before being loaded onto the robot. To access all portions of FlipCloud, all that is required is a login. These can be applied for online and once approved will give you access to all areas of FlipCloud. There are some areas of FlipCloud that don't require a login, such as Flipcode, meaning students can access the platform at any time. We will now look in depth at each section of FlipCloud to show exactly what is available. In the Case Curriculum section of FlipCloud, you can view the various topics available for FlipRobot. This shows not only the starter kit topics, being 1 and 2, but also the extension kit topics, so you can get an idea of the lesson plans involved in each extension kit. When selecting a topic, you are taken to the Curriculum Topics section. In this section, you can view and download both the program design and teaching resources for that topic. There is also a section to download the default firmware for this topic. If you want to use the variable control board for programming, then this is where you can download the firmware for that. There is also a section for coding samples. These are complete codes that can be loaded into Flipcode for that topic, which can then be used to deconstruct the meaning behind or get students immediately involved in coding a sensor. As an example, Topic 1 for the ultrasonic sensor comes with coding samples for an obstacle avoidance program, a maze runner program, and CoolDog, which causes the robot to retreat when sensing an object in front of it. The support page on FlipCloud is where the necessary extensions and drivers to run Flipcode reside. The Chrome extension and drivers for both Mac and Windows can be downloaded from this page. We will now look at Flipcode, Actura's online coding platform. To get access to Flipcode and begin coding, all you need is an internet connection and the relevant Chrome extension. As mentioned earlier, the Chrome extensions can be downloaded from the support page within FlipCloud. The Flipcode environment is in our FlipCloud and does not require a login to access. This way, students can access the environment at any time through any device with an internet connection. Once in Flipcode, all the relevant coding blocks will appear on the left-hand side of the screen, with programming logic being at the top and physical component functions being at the bottom. The coding blocks can be grabbed from the relevant menus as shown and added to the coding pane. The coding blocks easily snap into place to create different programs. Once your code is completed, all you need to do is connect your FlipRobot and switch it on, select the FlipBrain and port, and click Upload to upload the code directly into your FlipRobot. You can also save codes and load them back in using the save and load features shown here. In Flipcode, you can view the Blockly code as a script. This allows students to be introduced to script-based languages while using Flipcode. To be able to see the script language behind Flipcode, all you need to do is create some coding blocks and then use the button at the top right to be able to switch to the script language. From here, you'll be able to review the script language for the code you currently have in Blockly. This script will automatically update when any new coding blocks are added into Blockly. If you want to learn more regarding Flipcode, please refer to the Flipcode e-learning module for a more in-depth look at the coding environment. We will now look at the case curriculum for FlipRobot, the centerpiece to the whole solution. The case curriculum for FlipRobot was designed to be comprehensive but also flexible, with a focus on STEAM-related skills. As the curriculum is mapped to Actura standards, each lesson has a clear set of learning outcomes. The focus behind each lesson is the promotion of problem-based learning and design thinking. Each extension kit has its own curriculum, which adds its own level of complexity, resulting in a curriculum that delivers years of content, not hours. The curriculum is broken up into a series of topics that cover a sensor or extension kit. Each topic is made up of 4 key materials used to deliver the content. The first is the hardware. This is the starter kit for topics 1 and 2 and the extension kits for each topic associated with that kit. The hardware is what allows the physical outcomes of programming to be shown, as well as providing the sensors at the basis of the lessons. The next is the firmware. The firmware is what determines the default set of instructions FlipRobot will have and the modes for the variable control board. Each topic has its own set of default firmware, which is available in the case curriculum section of FlipCloud. Flipcode also contains all the programming elements required for each topic. From the light sensor in topic 3 to the LED ring in topic 4, these elements are made available on the same Flipcode environment, so it's a one-size-fits-all solution. Actura has also developed a series of sample codes for each topic. These are pre-made codes which can be loaded into the Flipcode environment to provide examples of learning outcomes and give the ability to deconstruct coding elements. The coding samples are available in the case curriculum section of FlipCloud. The final items are the program design and teaching resources. For each topic, Actura supplies a fully mapped program design with learning outcomes for each lesson within the topic, along with an accompanying teaching resources PowerPoint to accompany the lessons in the program design. These are available in the Case Curriculum section of FlipCloud inside each of the topics. We have now reached the end of this e-learning module. You should now be confident in the following areas of FlipRobot: robotics applications in STEAM learning, the hardware components incorporated with the FlipRobot, the resources available in FlipCloud and how they can assist you in classroom delivery, how to access Flip code and some of the applications of the platform, and what is included in each of the topics of our curriculum. There will now be a short quiz. Once passed, the topic will be complete.